Hi guys, and welcome to another video. And in today's video lesson, we're going to be looking at grade 10 maths trig graph interpretation. So trig graph interpretation, also known as functions or trig functions, we can just look at it just like any other function, like the parabola or the exponential graph or function. So we're going to get straight into it. It says here in the November 2019 paper 2, question 5, sketched below are the graphs of f of x equals to 2 cos x and g of x equals to sine x minus 1 for the interval from x element from 0 to 270. Now this is regarded as the domain, that is where the graph is drawn between the two x values, and this is the start here, okay, and then this one here will be the end. Okay, so if you are sketching this graph, that will be a start, that will be your end, right? F of x equals to 2 cos x. Remember that the amplitude of the graph now is going to be 2. Amplitude is the positive coefficient of your sine and your cos graph. So if you were asked for the amplitude, it will be 2. And don't forget now, see, this is your b value here. So the period is 360 over b, which is 360 degrees over 1, which is equals to 360 degrees. Always know your mother graphs like y equals to cos x, y equals to sine x, and y equals to tan x. See this graph here, g of x. It says equals to sine x minus 1. So it's the graph of sine x shifted 1 unit downwards. Alright, so this is a vertical translation. It's shifted 1 unit downwards. Let's see what questions they're asking us in this particular question here. So they're giving us these two graphs. We can clearly see that this one here is the cos graph, right? This one here is the cos graph. Let's just put a highlight on it here. So this one here is the cos graph, and as you can see here, it's going down here, right? It has you can see the maximum value there is 2, and then the minimum value there is minus 2. All right, and this is the cos graph. Remember, amplitude is maximum minus minimum over 2. So that's the other definition for amplitude, or the positive coefficient of your function. So maximum minus minimum over 2, so you can say 2 minus 2 over 2, which is 4 over 2, which is equals to 2. So you can work on amplitude like that too. Then the other graph that they gave us is the sine x minus 1. So you can see now, see, this is the sine x graph, right? And it's shifted 1 unit downwards like so, right? And you can see the intersection points are here. Right, so there's one intersection point there, and there's another intersection point there. So there's two places in which these two graphs cut each other and intersect each other in the domain from 0 to 270. There's my domain there. Okay, now let's see what questions they ask us in this particular exam question. So let's get straight into it. Then it says here, write down the period of f. So the period of f, 5.1.1, there we already discussed it. Right? What is the definition of period? It means like for, right? How long means how many degrees does it take to make one full cycle, and we work it out by, remember the standard form is f of x, or you can say y equals to a cos bx plus q. So that will tell us our period, that b value. So we just take 360 and divide it by b. You can say b is equal to 1 here, right? So therefore 360 over 1 equals to 360 degrees. So the period of f is equals to 360 degrees there. The range of g. Now the range of g, sine x minus 1. What's the definition of range? Range is as follows. So let's just write it here. Range, it's y element from your minimum to your maximum value. Your minimum is your minimum y value. Your maximum is your maximum y value. So therefore, the range will be y element. What's my minimum y value of g? The minimum y value of g, there's g here, is -2. That's the lowest y value it goes to. And the highest y value here is 0. So it will be from -2 to, it will go up here to 0. Okay, so therefore the y element here from -2 to 0. The number of solutions to f of x equals to g of x in the interval from 0 to 270. Number of solutions That means how many times do they intersect each other? That will be 1, 2 times they intersect each other. Okay, so the answer there will be 2. Then it says for which values of x in the interval from 0 to 270 is f of x times g of x greater than equal to 0. Now what they're talking about here in 5.2 is if I take the y value of f and I multiply it by the y value of g, where will it be positive? So basically I'm looking for a positive times a positive, which is equals to positive, or I'm looking for a negative times a negative, which is equals to positive. So what I'm looking for both above, both functions above, or I'm looking for both below the x-axis. When I say above and below, I mean above the x-axis, because y values above the x-axis are positive, right? And both below the x-axis, here now, x-axis, if both functions are below the x-axis, that means the y values are negative. So therefore, both above or both below. Let's see, right? So both above or both below. So I'm looking for where both these green ones now are going to be above, the green and the pink one, both above or both below. Let's see, right? So here you can see now, you see there's it above. So that's out. Why? See, because you're going to get a positive there times negative there, which is negative, right? So what I'm looking for now is here. See here, this is negative right through, its negative pink, right? And don't forget that 0 there, and then it's going to be 0 there where it cuts the x-axis. Negative, and that's also going to be negative. So a negative times a negative is going to be positive. So what's that now? It's between 90 and 270, right? It'll be negative and also it will be 0. So they said here greater than equal to 0, right? So once again, the answer will be between 90 and 270. So there I'll say x greater than equals to 90 degrees and less than equals to 270 degrees. Last question, 5.3. Yeah, they're saying the graph H is obtained by reflecting the graph G about the x-axis. Write down the coordinates of the minimum turning point of H in the interval from 0 to 270. Now, they are reflecting G about the x-axis. Write down the coordinates of the minimum turning point of H. Okay, let's see now. Where's G? There's G here. So they're going to reflect this graph about the x-axis. So what happens now when they reflect it about the x-axis? Remember that. See this point over here now, right? All these points are going to change now. So this point here is, what's this over here? This is 0 and minus 1. So this becomes 0 and positive 1. So you're going to get a point there. Okay? That 0 and 0 is going to stay the same. See this point here now. This point is, let's see what we have. Oh, there's it over here, right? So you got, what's this here? 270 and minus 2. So that's going to come up here. Let's just see if we can erase some of the stuff here. Let's take this out here, right? So we can see clearly what's going on here. So we're just reflecting the points to see what happens here. See here what you got. 270 and minus 2, right, is going to be here 270 and positive 2. Okay, so what's going to happen is your graph is now going to look something like this here. So it's going to come down here like that. Okay, there you go. And so you're going to have that point there. So it's going to go, what's this point over here? Okay, so this point here is where they intersect. So it's just going to be below there, right? But if you look carefully now, see that, right? It's not a, that's going to be the reflection. So the reflection is going to look something like this. It's going to be, if that goes up there like that, it's going to look something like that, right? So you can see now. So let's go answer the question. What do we have here? What do they say? They want now they're saying the graph H is obtained by reflecting the graph G about the x-axis. Write down the coordinates of the minimum turning point of H in that interval. So the minimum turning point of H in that interval will be this one over here, 90 degrees and 0. So that will be the minimum turning point. It will be 90 degrees and 0. Alright, and that will be the maximum turning point. What's a maximum turning point? It will be 270 and 2. 270 and 2 if they asked us for that one. Okay? So we have to know the rules for reflection about the x-axis. What's the rules for reflection about the x-axis? First of all, we can write down the function like this. H of x equals to, if you're reflecting about the x-axis, it's going to be minus g of x. That's the rule for reflection about the x-axis. Remember that you're just going to change the sign in front of the function. Okay, write down the coordinates of the minimum turning point of h in the interval from 0 to 270. Okay, so what is your function now? So g of x is, what's g of x? G of x is sine x minus 1. So therefore it's going to be minus into sine x minus 1 equals to minus sine x plus 1. So what is going to be? So it's going to be the, right, see the sine x graph, okay? So the reflected sine x graph plus 1 unit upwards, okay? But the best way for you to do that is if you look at just doing a reflection here about the x-axis. Don't forget that's the x-axis. Learners, if you haven't subscribed already, be sure to subscribe to jlmaths.com. Well, that's my website, jlmaths.com, but the YouTube channel is jlmaths, and you can also like my Facebook page, which is Justin Lazarus Mathematics. And I'll catch you in the next video.